In this video, we are going to look at an important theorem in circle, that is the meaning of angle in alternate segment. We will also be looking at the proof, but the proof may not always be needed, particularly in the school stage. But for class 10 level students, the application of this theorem is vital for many proofs. So first we will see what is the meaning of the angle in the alternate segment, and we will use a simple graphical illustration so that you can identify the angle in the alternate segment, and then we will give a very simple proof of the theorem. So first, meaning of angle in alternate segment. A chord divides a circle into two segments. Here you have a chord, this is a chord, and you have got segment 1 and segment 2. You have got a chord here. You can of course name it anyway. You can also call this one segment 1 and that segment 2. But anyway, we have two segments. Whatever be the naming, you can call this one segment 1 and this segment 2. And we have drawn a tangent through the end point of the chord. So when you draw a tangent through the end point of the chord, this is the common point of contact, the point of contact of the tangent with the circle, and one of the endpoint of the chord will be the same point. We have marked the segments, this as segment 1 and this as segment 2. So the two segments are marked 1 and 2. Now, the meaning of alternate segment means when we are talking of segment 2, segment 1 is the alternate, and when we are talking of segment 1, then segment 2 is the alternate. Alternate means the other segment. The chord is dividing it into two segments, 1 and 2. So for segment 1, 2 is the alternate segment, and for segment 2, 1 is the alternate segment. And we have got the BC as a tangent, and this is the angle made by the chord with the tangent. Supposing, let us call it alpha. This angle ABC has been called alpha, the angle made by the chord with the tangent. Now, what is the meaning of angle in the alternate segment? Now, this alpha, this lies in segment number 2. This alpha, this angle is lying in segment number 2. So, we have to seek an angle in the alternate segment, means in the segment 1. So, take any point D. You can take it anywhere. We could have taken this one, we could have taken this one, we could have taken this one, any point. And from there, we join the end points of the chord. Here we have joined D to B and D to A. So any point on the circumference in the alternate segment, not in the blue segment, but in the red segment, take any point D and join it to the two endpoints of the chord. So join AD and BD. And supposing this angle is beta, this angle we are calling it beta. The angle ABD, this angle we are calling it beta. So this is the angle in the alternate segment. So for alpha, the angle made by the chord with the tangent in the blue colored segment, the angle in the alternate segment in the red segment, angle beta or ADB is the angle. Now we have to prove that alpha and beta are equal. That's the theorem. Alpha and beta are equal. The angle made by the tangent of the chord in the blue segment will be equal to the angle in the alternate or the red segment, that is alpha must be equal to beta, and we shall prove it very easily. Suppose O is the center and we are joining OA and OB. So OB, this is an isosceles triangle, OAB. Why? This is radius and this is radius. So OA equal to OB, so there is an isosceles triangle. Now, also see that this angle at the center will be twice the angle at the circumference. So the angle at circumference is beta, this will be 2 beta. angle at the center is twice angle at the circumference. Now, radius is perpendicular to the tangent. Radius OB is perpendicular to the tangent. Angle, what is this angle? Because it is perpendicular, the whole angle must be 90 degree. Since the radius OB is perpendicular to the tangent, the whole must be 90 degree, and this one is alpha, so the remaining angle is 90 minus alpha. And when this is 90 minus alpha, this is also 90 minus alpha, because there is an isosceles triangle, radius OA equal to radius OB. And angle at the center is twice beta. Why? Because angle at the center is twice the angle at the circumference. So we have in this triangle, angle OAB equal to angle OBA equal to 90 minus alpha. This one and this one, we get 90 minus alpha. The full is 90 because radius is perpendicular to the tangent, and this is alpha given, so the remaining one will be equal to 90 minus alpha. And the angle AOB is twice beta because it is double the angle at the circumference. Now the sum of the angles of the triangle is 90. So 90 minus alpha, that is this angle of the triangle, plus 90 minus alpha, that is this angle of the triangle, and twice beta, which is this angle. The sum of the three angles must be 180. So you cancel 90 here, 90 here, 180 here. You'll get minus 2 alpha plus 2 beta equal to 0. That is beta minus alpha equal to 0, or beta equal to alpha. So we have proved that this angle is equal to the angle in the alternate segment. But then, as I told you, that rather than the proof, it's important to identify the angle in the alternate segment. And whenever in any question you have got a tangent and a chord making an angle, always use the concept that angle in the alternate segment is equal to the angle between the tangent and the chord. So that was our video from Easy Elite English Education Trust. We hope you found it useful. We'll be coming back with more videos. Till then, thank you and goodbye.